Our first example is y to the negative 7th. Based on what we just learned about how to interpret negative exponents, we know that we can write this as 1 over y to the positive 7th. So this is 1 over y to the 7th. And we're already finished with that one. Let's try then the quantity 3 times x to the negative 1. Just like before, if we had 3 times x to the third power, we would have to apply this exponent of 3 to everything inside the parentheses, 3 to the third and x to the third. Now we're going to apply the negative 1 to both things multiplied inside the parentheses. We have 3 to the negative 1 and x to the negative 1. Well, 3 to the negative 1 is 1/3, 1 over 3 to the first power. X to the negative 1 is 1 over x to the first power. So 1/3 times 1 over x is 1 over 3x. And as you practice these, you'll be able to get in the habit of seeing that, okay, well, if I'm raising the whole thing to negative 1, it's just 1 over that entire quantity, 3x. So 1 over 3x is our answer for this one. 4c to the negative third is our next example. And as opposed to the last example, there's still a negative exponent, but there's no longer a set of parentheses. That means that the 4 does not have the negative 3 exponent applied to it. The negative 3 is only acting on the c. So in this case, the 4 remains where it is, and the c to the negative 3 gets rewritten as 1 over c to the third. So we can think of this as 4 over 1 times 1 over c to the third power, and we can write that as 1 fraction 4 over c cubed, or 4 over c to the third power. Another thing you might see is something with a negative exponent in the denominator. And this is going to be confusing the first time you see it, first few times you see it, honestly. But that's okay, just work through the logic of what you know a negative exponent means. I'm going to rewrite this actually as a division equation. This is 1 divided by x to the negative 2. We know that x to the negative 2 can be written as 1 over x squared. Then we also know that dividing by a fraction is the same as multiplying by its reciprocal. So the reciprocal of 1 over x squared is x squared times 1. 1 times anything is just that thing, so 1 times x squared over 1 is x squared over 1, and dividing anything by 1 yields what you started with, so our final answer is x squared. Let's think about that for a second. If you have a base with a negative exponent in the denominator, now we've taken that base and its exponent and put it back in the numerator with a positive exponent. It's essentially the reverse of what we were doing before. But you'll probably need a bit more practice with it before you're really comfortable taking negative exponents from the denominator to the numerator. So let's look at a few more examples. Let's try 2x over negative a to the negative 4th power. We're going to break this down step by step like we did in the previous example. Let's think of this again as a division problem. This is 2 times x divided by negative a to the negative 4th power. The first thing I'm going to deal with is writing this negative exponent as a positive exponent. To do that, I need to put it in the denominator. Since I've got a negative here, I'm going to think of this as a negative 1 times a to the negative 4th. This means the negative 1 is going to stay in the numerator, and the a to the negative 4 is going to go to the denominator and have a positive exponent. So now I'm taking 2x and dividing it by negative 1 over a to the 4th. So I'm dividing by a fraction, which means I can multiply by that fraction's reciprocal. So 2 times x times a to the 4th divided by negative 1. I can think of 2x as 2x over 1, so 2x times a to the 4th, I'm going to write as 2a to the 4th times x. And the reason I put the a to the 4th before the x is because I'm used to writing expressions with variables in them in alphabetical order. It's the way you're going to see most textbooks write things and most problems presented to you. In the denominators, I've got 1 times negative 1, so I've got a negative 1 here. Dividing something by negative 1 makes it negative. So I'm going to simplify this and say negative 2a to the 4th x. And that's our final answer. Our next example says 2 times n to the negative 2 over 3 times p cubed. The 2 is not going to go anywhere because it's not raised to a negative exponent. The 3 is not going anywhere down here because it's not raised to a negative exponent. Neither is p to the third power. But n to the negative 2, we know we can write as 1 over n squared. And as we've seen in the last couple of examples, these things can get moved with other stuff around them. So we're going to write n to the positive 2 in the denominator here. And I'll clean that up a teensy bit. I'll write my 2 more centered, and then I'm going to put this also in alphabetical order. So 3n squared p cubed in our denominator there. So 2 over 3n squared p cubed is our final answer. Our next example says negative 3b over 5c to the negative 1. We saw one that was pretty similar to this when we had a to the negative 4th in the denominator. So I'm not going to go through every step on this one because I think we are ready to move on to doing it in one fell swoop. The negative 3 doesn't go anywhere, b doesn't go anywhere, neither does the 5 in the denominator, but what happens when we have a negative exponent in the denominator? It means we move it up and we write it with a positive exponent. So now c to the first power gets written in the numerator, and we know c to the first power is really just c, so I'm going to drop writing that exponent, and my final answer is negative 3bc all over 5, or negative 3bc fifths. What if we had the fraction 2/5 all raised to the negative 2 power? Well, let's go back to what we know about raising fractions to an exponent. Before, if you had 2/5 to the third power, you would distribute the 3, the exponent of a 3, to both the numerator and denominator. You would say that this is 2/3 over 5, 2 to the third over 5 to the third, right? Because 2/5 cubed is really 2/5 times 2/5 times 2/5, which is 2 cubed over 5 cubed. So 2 cubed is 8, 5 cubed is 125. That would be our final answer. Let's apply that process to our question in blue, 2/5 to the negative 2 power. We'll be able to distribute the negative 2 to both the 2 in the numerator and the 5 in the denominator. Now we have something in the numerator that has a negative exponent and something in the denominator that has a negative exponent. If we dealt with each of them separately, we would realize that the 2 to the negative 2 can be written in the denominator with a positive exponent, and that the 5 to the negative 2 that's currently in the denominator can be written in the numerator with a positive exponent. So essentially, these two are going to switch places and have their exponents become positive. So 5 squared is 25, 2 squared is 4, 25 fourths is our answer. Let me point out that we also could have thought of it this way. 2 to the 5th to the negative 2. Notice that we ended up at this step where we had 5 squared over 2 squared. When you have an entire fraction raised to a negative exponent, you can take the reciprocal of the fraction and raise it to the positive exponent. Okay? Because what's really happening is the numerator and the denominator are both having a negative exponent applied to them, which means they are just going to swap places to make the exponent positive. Swapping places means taking the reciprocal of the fraction, switching where the numerator and denominator are. So let's practice what we just figured out. Here's another fraction, 5x over 3y times z, all raised to the negative 3 power. Well, there are two ways we can do this. One, we could distribute the exponent to the numerator and denominator separately, and then flip places, so 3yz to the third over 5x to the third. But remember that this is the same as writing 3yz over 5x all to the positive 3. We can do it either way because these things are equivalent. Okay? In the one up here, the exponent has already been distributed, and here it hasn't been. But they are mathematically equivalent, so you can do either one. Let's go further and evaluate the rest of this. So 3 to the third power, okay, I'm going to distribute the exponent now into everything. 3 to the third power is 27. Y to the third power is y to the third power. We've got z to the third power. In the denominator, we've got 5 to the third power, which is 125, and x to the third power, which is x cubed. So our final answer is 27y cubed z cubed over 125x cubed.